So for naming ionic compounds, it's kind of important to realize that I'm only going to be presenting you with binary compounds, meaning they have two different pieces. So when you see more than one element, then you actually should note that there's probably a polyatomic ion in there. But let's look at, I have it set up this way to be different cases that you can encounter. So case 1 would be if you just have two elements bonded together. So remember that to be ionic, you have to have a metal and a nonmetal, meaning something from the left of the stairs and something from the right of the stairs. The metal is going to be, for this case, only from group 1A or 2A. Okay, so our example here is going to be MgCl2. So whenever you have just two elements, you basically just name them what they are. So the first thing, the cation, is going to be magnesium, because that is what Mg stands for. And the second thing is going to be whatever its element name is, but remember that you change the N to IDE. So that's going to be magnesium chloride. Okay, so that's kind of the simplest case. So IDE being the important part there. All right, does anybody still need that? So case number 2 is when you have two elements, but this time the metal is not in 1A or 2A. So it's another metal. All right, this is where the Roman numerals come into play, because again, you have to say what the charge is, because the charges can vary for most other metals. So the example we're going to use here is going to be FeCl3. So in order to figure out what the Roman numeral is, you have to work backwards in order to figure out what the charge on the metal is. So by doing that, because I have 3 chloride ions, then that's going to be a -1 charge times 3, giving me a total of -3 on this side. Okay? So, because I only have one iron, since there's no subscript written there, that's a 1, understood, then my charge has to be +3. If my charge is +3, then my name has to include that as the Roman numeral. So it's going to be iron, parentheses, Roman numeral 3, chloride. So once again, the Roman numeral is indicating the charge of the metal, not how many there are. Okay? All right. Case number 3 that you can see is basically going to be our exceptions to case number 2. Okay, and those exceptions were silver, cadmium, zinc, and aluminum. Right, so those 4 you definitely just need to memorize as being exceptions to the rule. And again, it looks on the periodic table kind of like a little Z or a puzzle piece. That's kind of how I remember where they are. But you can also, if you remember them in order, then they also go in order of charges. It's +1, +2, +2, and then aluminum is +3. Okay? So given that, because their charges always stay the same, then you don't need to worry about a Roman numeral, and you would just name it the way you normally would. So if we have ZnCl2, then it would just be zinc chloride. Okay? Alright, and finally, case 4. Case 4 is going to be where you have more than 2 elements. So again, I'm only giving you binary compounds at all in this class to name. So whenever you see more than 2 things, that means that something is a polyatomic ion. So this is for when you are dealing with polyatomic ions. Remember that a polyatomic ion is a group of atoms that's going to act as a single ion. They all act together as one thing. So our first example is going to be Ca parentheses ClO3 2. And remember that the parentheses are showing us that we have 2 entire chlorate groups, and those are going to be that way to balance out a +2 calcium. So in order to name that, you just name things with polyatomics as whatever they are. So it'd just be calcium chlorate. So like I said, anytime you see more than 2 things, that should set off a red flag that says there's a polyatomic ion here. That's also why it's a good idea to learn some of them, because then you just start to recognize them and it makes it easier and faster. So here's kind of the most complicated formula I could give you. But it's actually a pretty similar name. So remember that phosphate is normally -3. Ammonium is +1, so I need 3 of them, which is why there's a 3 outside of the parentheses. So even though, or because these are both polyatomic ions, you just name them the names of the polyatomic ions. So ammonium phosphate. But you'll notice that that compound actually has 4 different elements in it. It's still acting as only 2 pieces.